So in our 10th question, we have a light rod connecting two masses, each of mass m, and each one moving with a velocity v0. So this whole system is moving in a horizontal frictionless surface, and in the path comes a small mass of mass m. A collides to C and sticks to it. Now we need to find out the linear speed of A and B after the collision, and we also need to find out the velocity of center of mass of A plus B plus C system and the angular velocity of the same. Now for solving this question can be solved by multiple methods. We have to choose the best and the easiest method. Now we realize that before and after the collision, let us draw the diagram. This is the diagram before the collision, and this is the diagram after the collision, where here we have a mass 2m and here a mass m. This is m and m. So this will be moving with some velocity v dash. This will be moving with some velocity v double dash. Now we realize that the only force acting on this object in the horizontal, there is no force acting on this object in the horizontal direction. The only force acting on it is the force due to rod, which will act along the length of the rod, due to which the net external force on this object is 0, due to which the momentum of this system of this object will remain constant. Therefore, the velocity of this object has to remain constant. So we directly now know the velocity of this object. So our first part answer, velocity of v is equal to v0. Now we need to, by applying the same logic on the system of A and C, the net external force acting on the system of A and C in the horizontal direction is 0, due to which the momentum of this system has to remain conserved. Therefore we can write mv0 is equal to 2m v double dash. When both of them stick together, they move with the same velocity v double dash. So v double dash comes out to be v0 upon 2. So we can write this as v0 upon 2. Now we need to find out the linear velocity of the system and the angular velocity of the system. So the first thing you should do is find out the center of mass of the system. What people generally do is that they take this to be the center of mass, they assume this to be v and this to be omega, and they commit a mistake, because this is not the center of mass now. What you have to take is the new center of mass of the system after this mass has combined with this mass. So the center of mass of this system comes out to be at L/3 distance from the lowermost mass. To find out the distance of center of mass, there is a direct formula. In case of 2 point masses, the distance of center of mass from one of the objects is equal to the mass of the front wala object into the total distance upon total mass. That is equal to L/3. So this is a shortcut. The distance of center of mass from mass 2m will be mass of m into total distance upon total mass, that is equal to L/3 from here. So here we know as the center of mass of the object. This is v. The angular velocity is omega like this. So what we can write now is that we can write any one of the two equations. V, the velocity of this object according to the center of mass will be, we'll first see rotation about center of mass, that will give us omega into 2L/3 plus v is equal to v0. This is one equation. The other equation is omega into L/3 this side. Let me write it here. Omega into L/3 this side and v added this side to give the combined velocity of this point mass, and that is equal to v0 by 2 as we know. Therefore v minus omega L/3 is equal to v0 by 2. You can write this as v minus omega L/3 is equal to v0 by 2. So we have two equations, two variables v and omega. You can solve the question from here. But there is another way in which you could have got the answer directly. When we look at this whole system is experiencing no external force in the horizontal direction. So the momentum of the whole system in the horizontal direction remains conserved. So we can write this as 2mv0, that was the initial momentum of the system, initial velocity of this object was 0, is equal to final momentum of the system. Now momentum of a system can always be written as, there is also a formula, momentum of system is equal to mass, total mass of the system into velocity of center of mass. This is equal to m1 v1 plus m2 v2. We generally use this formula and we forget this formula. So this can be written as 3m into VCM. So VCM comes out to be 2v0 upon 3. So we get the answer for V directly. We could have got the same answer from here also. Now if we substitute this V over here in any one of these two equations, we get the value for omega also. Omega comes out to be V0 upon 2L. So we get the answer for the velocity of particle A as V0 by 2. Finally, the particle B, its velocity finally remains the same as V0. The velocity of center of mass comes out to be 2v0 upon 3, and the angular velocity of the system about the center of mass comes out to be v0 upon 2L. You could have also thought of writing equations of angular momentum conservation about this line, but that will become difficult, but that is just a thought you can also give. So in these type of rotation questions, it is not being used in this question, but there is another thought which you can give, that is about of angular momentum conservation about this axis, because the net external torque on the system, when you take this into the system along with this, comes out to be 0 along this axis. That is just a thought, and but the answer for this question comes out to be velocity of center mass is 2v0 upon 3, and the velocity of this object is v0. This one is v0 by 2, and the omega comes out to be v0 upon 2L.